Hey everyone, this video is going to be a demo of Pathfinder, which is a demo of the A-star pathfinding algorithm. I built this myself. I built it with a library called GridGraph, which I also built myself, which is based on part of a library called props.js, which I also built myself. And I'll talk about those a little bit more after I give you a little demonstration of this application. So, like I said, this is a demo of the A-star pathfinding algorithm, and the way the A-star pathfinding algorithm works is that it takes a start node and it takes an end node, and then it finds the most efficient path between them. And I'll leave some resources in the description of this video, and I'll leave some, there will be some on the landing page for this project, which, if you're watching this, you probably came from that landing page, so just go back, and I'm not sure where I'm going to put the resources yet, but it will be somewhere in there. I'm in the process of building that landing page as I record this. So, like I said, this A-star pathfinding algorithm takes a start node and an end node, and it finds the most efficient path between them. So, what this app allows you to do is pretty much just watch that happen and draw mazes and stuff and watch the algorithm solve it. So I'm going to start by placing a start node here, and all you have to do is click. It will actually start with in the start node placing mode, and then once you place your start node, it will automatically switch to placing the end node. So you just got to click again. And if you want to remove your start node or your end node, just click on the one that you want to remove, and then click the square where you've placed it, and it will remove it. So once we have a start node and an end node, we can click go in the top right hand corner, and we can watch it solve we can watch it find the most efficient path between the two nodes. Now, if this isn't very interesting, this is basically mostly just a straight line between the two nodes. So to make it more interesting, I added the ability to place obstacles. So we could place a start node and an end node, and we can place either a regular obstacle, which is just 1 square by 1 square, or we could place a large obstacle, which is 3 squares by 3 squares. And you could draw pretty much any kind of maze you want. Be advised that my implementation of this algorithm can be stumped. So I'll leave it to you to try and stump it. But it should be able to take care of this pretty easily. So let's click go and watch it navigate the environment that we've laid out for it. Here we go. So it's found a path, but there is a problem with my implementation, and this is something that I have to look into, and I plan to look into going forward. There is a problem with it, which is that it doesn't find the optimal path a lot of the time. If we look at the sections of the path like this, we can see that it is going up only to go down again. And the A-star pathfinding algorithm is supposed to find the most efficient path, but there's no way that this is the most efficient path, right? Because it goes up and then it goes down. It could have just cut straight across and saved itself some travel time. But that's something that I plan to look into, and an interesting little problem for me to work on over the coming weeks. I'll probably look at some other implementations of the A-star pathfinding algorithm, particularly Coding Train. If you haven't heard of that channel on YouTube, he's a really, really great programming enthusiast and an expert who does all kinds of coding challenges, and he has an implementation, a video where he makes an implementation of the A-star pathfinding algorithm. So I'll probably check that out and see what he does and compare our implementations. I'm sure his is much more efficient and accurate than mine, because he is a very, very good and experienced programmer. Some other things that I wanted to touch on in this video is how I made this. This is based on, I think I mentioned at the beginning of this video, that this was based on a library that I built called GridGraph. So GridGraph is a library. It's a JavaScript library for building mainly cellular automata, like Conway's Game of Life. And if you don't know what a cellular automata is or what Conway's Game of Life is, I suggest you do a quick YouTube search because it's possibly one of the coolest things um, in computer science. Um, yeah, GridGraph is a library for building grid-based visualizations, simulations, and animations. And just to give you a quick rundown about how it works, this isn't supposed to be a video about GridGraph, but each one of these squares is it actually holds a reference to all of its neighbors. So that kind of makes it kind of similar to a graph data structure where every cell is a node, and it stores it has a relationship or an edge that points to all of its neighboring nodes. So yeah, grid graph can be used to build a lot of interesting stuff. Pretty much anything where a programmable grid of cells would be useful. And there are a couple projects. I do have an implementation of Conway's Game of Life on my portfolio, and you can check that out on my GitHub as well. And that uses GridGraph as well. Yeah, I hope you have fun using Pathfinder, and I hope you have fun trying to stump it. It can be stumped. It can be you can beat it, if you will. There are definitely mazes that you can draw that it won't be able to solve. And I'm gonna keep trying to make it better, and hopefully you'll keep coming back and trying to beat every new implementation that I make. So it's kind of like your cunning against mine, or against my how fast I can develop my ability to write this algorithm better. So yeah, have fun, take a crack at it, and yeah, hope to hear from you. Thanks for watching.